Welcome everyone in lecture number 17. Today I'll discuss second shifting property of inverse Laplace transform. So before starting this property, let me first state the same property for Laplace transform. And that property says that if Laplace transform of ft is equal to fp, then we are given this type of function which is equal to f of t minus a for t less than for t greater than a and 0 for t less than a, then Laplace transform of gt is equal to e raised power minus ap fp, where fp is the Laplace transform of ft. Means when in this function we replace t minus a by t, then we'll get ft. So we'll take the Laplace transform of ft to get fp and multiplied it by e raised power minus ap if we have negative a here. If we have positive a here, then we have minus of minus a, because t plus a in when you write t plus a in the form of t minus a, then it will be written like this. So a will be negative, so we put here negative a, that will make negative of negative a will be positive. Okay, so in case when we have positive sign here, we have positive sign here. When we have negative sign here, negative sign here. Okay. So now state the same property for inverse Laplace transform now. So if Laplace inverse of fp is equal to ft, then Laplace inverse of e raised power minus ap fp is equal to gt. Means if we are given the function which is multiplied by exponential function, then its Laplace inverse is equal to gt, where gt is a function which is obtained by ft, which is the Laplace inverse of fp, by replacing t by t minus a when we have negative sign here. So we write gt like this. Okay, so इस प्रॉपर्टी का यूज आपको तब करना है जब आपको ऐसे फंक्शन का लाप्लास इनवर्स फाइंड आउट करना हो जिसमें एक्सपोनेंशियल फंक्शन से मल्टीप्लाई हो रहा हो. अगर एक्सपोनेंशियल फंक्शन नहीं भी है तब भी हम उसमें एक्सपोनेंशियल फंक्शन एज्यूम कर सकते हैं बाय टेकिंग a is equal to 0. Okay, so let me show you how to use this property by taking one example. Evaluate Laplace inverse of p plus 1 over p square plus p plus 1 e raised to the power minus pi p. Okay, तो सबसे पहले भी एक्सट्रैक्ट fp. fp क्या है? एक्सपोनेंशियल फंक्शन को छोड़ के बाकी का जो फंक्शन है वो fp है. दिस इज fp. तो हमें fp का लाप्लास इनवर्स लेना है सबसे पहले. तो हियर fp is p plus 1 over p square plus p plus 1. तो यहाँ पर हम लाप्लास इनवर्स फाइंड आउट करने के लिए fp का फर्स्ट शिफ्टिंग प्रॉपर्टी का यूज कर सकते हैं. लाप्लास इनवर्स की फर्स्ट शिफ्टिंग प्रॉपर्टी जिसमें if we are given the function of p plus a or p minus a, then its Laplace inverse will be e raised to the power plus minus at into Laplace inverse of fp. Okay, so first of all, because this is a quadratic equation, we make the perfect square of this equation. So when we make perfect square of this equation, this will be p plus half whole square plus 3 by 4 type of expression. Because this is p plus half type of expression, so we split this one into half plus half. Okay, so now we write here Laplace inverse of fp is equal to Laplace inverse of p plus half over p plus half whole square plus 3 by 4. Now separate this expression and this expression. Okay, we take p plus half with this and half with this, so that we'll get two expressions. One is Laplace inverse of p plus half over p plus half plus 3 upon 4, and second expression is L inverse of half over p plus half plus 3 upon 4. Now this is a function of p plus half. According to first shifting property, if we are given a function of p plus a or p minus a, then Laplace inverse of f of p plus a or p minus a is equal to e raised to the power. If we have positive sign here, then we have negative a here, and if we have negative sign, then we have positive sign here, at into Laplace inverse of fp. Okay, this is the first shifting property. So this is equal to e raised to the power. Here we have positive a here, so we have negative half t into Laplace inverse of fp. Fp means you replace p plus half everywhere by p, so you'll get function of p square plus 3 by 4 by using first shifting property. By using first shifting property of inverse Laplace transform. And second expression is again a function of p plus half. This is also a function of p plus a, p plus half. A here is half. Okay, so this is equal to e raised to the power minus half t Laplace inverse of half over p square plus 3 upon 4. Both are from first shifting property. Okay, so this is e raised to the power minus half t. Its Laplace inverse will be cos root 3 by 2t, because if we make the square of this is root 3 by 2 whole square, so it's p upon p square plus a square type of expression, which Laplace inverse is cos at. Plus here we need root 3 by 2 in the numerator, because here we have root 3 by 2 whole square. So 1 upon 2 will take outside, because there is no use of this inside the bracket, and we multiply and divide this whole expression by under root 3 by 2, so that we get 2 by root 3 outside the bracket, and rest one is sine root 3 by 2t. You can cancel out these two, and we can take e raised power minus half t common. We can also take under root 1 upon under root 3 common, so that we have this expression. Let me write on the next page. Laplace inverse of fp is equal to e raised power minus half t divided by root 3 cos root 3 by 2t plus sine root 3 by 2t. So this is our ft. Now we are ready to write the value of gt. So by second shifting property, or you can say theorem, Laplace inverse of e raised power minus pi p into p plus 1 over p square plus p plus 1 is equal to gt, which is equal to f of t minus a. So a here is half. So sorry, a here is pi. So we replace t by t minus pi everywhere, so that we get 1 upon root 3 e raised power minus half t minus pi uh, root 3 cos root 3 by 2 t minus pi plus sine root 3 by 2 t minus pi for t greater than pi and 0 for t less than pi. So we replace t by t minus pi everywhere, because we have negative pi here. When we have positive pi here, we replace t by t plus pi. Okay. So this is the answer. Let me show you the second example very quickly, so that the concept of second shifting theorem will be more clear. Example number 2. Find Laplace inverse of e raised to the power minus 4p whole divided by p minus 3 raised to the power 4. So here you can see that the function fp, when you compare this by e raised power minus ap fp type of expression, the value of fp will be 1 upon p minus 3 raised to the power 4. So ft will be Laplace inverse of 1 upon p minus 3 raised to the power 4. So by first shifting theorem, its Laplace inverse is e raised power 3t, and Laplace inverse of 1 upon p raised to the power 4, which is equal to e raised power 3t, t cube upon t factorial, which is equal to 1 upon 6 e raised power 3t, t raised power 3. So by second shifting theorem, this is nothing but ft. Okay. So by second shifting theorem, Laplace inverse of e raised power minus 4p upon p minus 3 raised to the power 4 is equal to gt, which is equal to, we replace t by t minus 4. Okay, for t greater than 4 and 0 for t less than 4. Okay, next is example number 3. Laplace inverse of, find the Laplace inverse of e raised power 4 minus 3p whole divided by p plus 4 raised to the power 5 upon 2. So here we write this like this: e raised power 4 over p plus 4 raised to the power 5 upon 2 into e raised power minus 3p. So this is a e raised power minus ap type of expression, which is extract from this expression, and the function that is obtained, that is this function, this is taken as fp. ओके, इसको हम fp लेंगे, तो हम इसका लाप्लास इनवर्स फाइंड आउट करेंगे. लाप्लास इनवर्स ऑफ e raised power 4 over p plus 4 raised to the power 5 upon 2. So e raised power is constant, so we'll take it outside. We'll take the Laplace inverse of 1 upon p plus 4 raised to the power 5 upon 2. So by first shifting theorem, its Laplace inverse will be e raised power minus 4t into Laplace inverse of 1 upon p raised power 5 upon 2. So this is equal to, let me draw a line here. Okay. So this is equal to e raised power 4, e raised power minus 4t, and Laplace inverse of 1 upon p raised power 5 upon 2 is t raised to the power 3 upon 2, because one power is 1 is reduced from 5 upon 2, and here we have gamma 5 upon 2. So this is equal to e raised power 4 1 minus t raised power 3 upon 2, and this is 3 upon 2 1 upon 2 root pi. Okay, because gamma 5 upon 2 is 3 upon 2 gamma 3 upon 2. Okay, then gamma 3 upon 2 is 1 upon 2 gamma 1 upon 2, 3 upon 2 1 upon 2 root pi. Okay, so this is equal to 4 upon 3 t raised power 3 by 2 e raised power 4 1 minus t, this is 1 minus t whole divided by root pi. So this is our ft. So by second shifting theorem, Laplace inverse of the given expression, that is e raised power 4 minus 3p over p plus 4 raised to the power 5 upon 2, is given by f t minus 3, because a is minus 3. Okay, for t greater than 3 and 0 for t less than 3. So we write this as 4 upon 3 root pi also will write with 3, and t will be replaced by t minus 3 raised to the power 3 upon 2 e raised power 4. We put a big bracket here, 1 minus, then smaller bracket for t minus 3, then close the bigger bracket. Okay, and here we'll write t greater than 3 and 0 for t less than 3. Okay, so this is how we write our function of t in terms of gt. This is gt. Okay, this is nothing but gt. So I hope you understand this lecture clearly. You understand the second shifting property of inverse Laplace transform. So try more problems by yourself, and if you have any problem in any question, you can ask me. Thank you for watching the video.